Good morning, chat. My name is Penbu. I'm the programming, puzzle gaming, and music making VTuber on Linux, and today we are programming for once, finally. Sorry about the delay. Got off work a little bit late and then realized that I don't have the energy to stream unless I eat, so I had to go make some food. But how are you all? I hope we're all doing well. Today we are going to be doing a little bit of code golf. Code golf, much like regular golf, is where you try to minimize the number of strokes. And in this case, instead of putts, we are trying to minimize the number of characters. So here we have a bunch of programming puzzles, and our aim is to try to solve these puzzles in as few characters as possible in a given language. Today we're primarily going to be working in JavaScript. I may pull out Bash, but we're probably going to stick to just those two languages because those are the two that I'm most comfortable with, and so it'll be easier to golf. Why don't we start with FizzBuzz? Because we always do that. Print the numbers from 1 to 100 inclusive, each on their own line. And I think this is too small for you to read, so I'm going to make that a bit bigger. If, however, the number is a multiple of 3, we can print fizz instead, and the number is a multiple of 5, then print buzz. If multiple conditions hold true, then all replacements should be printed. For example, 15 should print fizz buzz. We've done this a number of times. Here we have byte solution is 58, and we have 53 characters. Char solution is 101 bytes. So we have a lot of stuff to beat. I tried this a little bit before the stream, and I couldn't get anywhere close to these people. So let's at least see how far we get, or how close we get. I'm gonna switch to JavaScript. We do have some convenience functions here. We have prints. It's mostly a print there. So I think that's the important part. So if we were to do this normally, we'd probably do something like for I equals 0 or I equals 1, I is less than 101, or less than or equal to 100. I'm gonna intentionally do this in a non-golfing way, just so we can see how the approach is, and then maybe future ones we could just go straight to golfing. So we have a for loop, right? And then we have, what is this? If I is equal to or is a multiple of 3, then we're gonna use the one approach where we do where we try to build a string instead. So let's results equals empty string. If I is a multiple of 3, then we say that results plus equals fizz. And then if I is a multiple of 5, actually these should be zeros. And results is equal to buzz, and then if results is the empty string, then results is equal to I instead as a string. Actually, we don't care that it's a string. And then after all that, we do print and results, and that is it. I don't want to run this. Actually, maybe I should run it. I actually don't know if I get on the leaderboard, but if I try to run it, so that's why I don't want to run it. We're gonna do this in a private window. FizzBuzz, just so we see that this actually does run. And it does pass, but you see that we are way over everyone else here. So the thing with code golf is that, one, you do not want to use spaces where possible. So get rid of all these spaces and all the unnecessary ones. Karma Komodo, welcome in. I see a problem. What is that? So get rid of all the spaces. I think we can get rid of some more. So this we can get rid of this one. We can get rid of this. And this. It's a lot of stuff to go through. Okay, so those are all the spaces, I think. We don't need lets. Because variables that aren't declared and that are written to will just be created by themselves. We can get rid of all these spaces too. And then we can save a character here by, instead of making this equal to less than or equal to 100, we can make it less than or equal or less than 101. So that we save the equal sign there. And then we can run this. And it continues to pass. But we're still a ton of characters over. Oh, actually, we still have these ones. But we're still a ton of characters over. So what else can we get rid of? We can probably get rid of these. Well, one, result doesn't have to be so large. It can be R. Or you don't need to be verbose anymore when you're doing code golf. And that gets us down to 91. And what else? We can try to get rid of these. Braces. Actually, no. We'll start with this one. We don't need this. The equals 0. Because one thing we can do is if we do the negation of it, so we can do it this way if we really wanted to. So that saves a character, I think, because this is 1, 2, and then 3 characters, whereas this is 1, 2, 3, 4. So we can do that way. So we save a character for each of these, and then for this one we can simply do not R, and then just assume that it's falsy, because R is only ever going to be a string. So we get down to 85 characters now. Now let's run that. That still works, but I think we can still get it down further. If takes up a lot of space. And I don't think we need the if. One thing we can do is turn the if into a ternary, because apparently doing something like this is, so just to demonstrate here, apparently that's a syntax error, because I don't know, the JavaScript parser sees this as the left hand side and doesn't like it. So one way around that is to put this into parentheses here to force this to be an expression instead of a statement. And so that'll work, but I think we can get down even further. So one, we can get rid of this, and we can do, we can turn it into a ternary, and we use the else clause here. So that got rid of these characters, so that's 3, and then everything else to do with the ifs. So that takes us to whatever this is. And then we also do the same here. If R then 0 or R equals I, and then print R. I think that gets us down to, so that does still work. That gets us down to 74 characters. We can go down even further. Obviously, it's starting to look pretty unreadable, but that's the point of Code Golf. And you're not optimizing for readability, you are optimizing for length. We can get rid of this semicolon, because that's redundant. And then we can actually get rid of this entire thing here, because we can say if R, print R or I, and save the assignments. We can get rid of that entirely. I think this should still work. Very good. I suspect this might be a little bit hard to follow once we start getting down here, so let me know if it does, and I'm happy to re-explain things. We can get rid of these braces. And we can do that by turning this thing into an expression so that it's a single statement. We can use the comma operator to combine these now expressions. Because a for loop will take a single statement if you don't have braces. Can we get down even further? We got down to 66. I think it's about where I left off with the thumbnail, but I think you can actually get down further. I just have to remember how. I think I'm gonna copy this and then see side by side how this compares. There is a trick that people have used before, where you do something like this, where you do ++i is less than 101. So you save that, but then you also have to do I equals 0 over here. So it actually ends up being the same thing. So maybe this doesn't actually save anything. Turn this into a do while loop, but I don't think that's going to do anything. Can we get down even more? There's got to be another way to, because this for loop is pretty large. There's got to be a different way. We do have array, say 100, or dot fill, dot map, where you have this, and then most of this stuff here. But that actually ends up being longer, because you have this. So I think 66 might be the best that I can do, which is about 10 characters more than everyone else's. Now I have no idea how they shaved off 10 characters. It's got to be something in the for loop. There's for sure. Ah, okay, hold on. I think you can shave off this. Okay, so we're now down to 65 characters. Or not. We got rid of 1. How do we get rid of 1? Because this has to start at 0. Run again. And then this needs to go to 100. Well, plus I. We can do that. Using Python, I used 118 characters, and the record was 53. Yeah, right. Although if this is your first time doing Code Golf, it's there are definitely a lot of tricks that you wouldn't have guessed unless somebody shows them to you, or you think about how the language works. I don't know how to golf effectively in Python, in part because I don't really write in Python at all. So I don't know all the tricks that you can use in Python. Okay, I'm doing something wrong here, so this is 101. Okay, so this works. We're now at 65 characters. We need to get down by 9. Now I'm feeling these ternaries are probably part of the issue, but I don't know how. Can we do something like... T equals I... No, that's not gonna work. Because you need them to be... You need these to be executed after the ++ I. But I think, I don't know, this might be as low as we can go for now. I can't see anything. There has to be something here, because otherwise it's a syntax error because you don't have an expression in there. So this definitely has to have something there. Is there a way we can reduce this down? I don't think trying to deduplicate the ZZ is going to do anything, because it's 2 characters, and anything more, any attempts to try to compress that is not going to work. But maybe I'm missing something. Maybe there is actually something. For I equals 0, is there a way we can assume that I is undefined? So going here in the node REPL, can we do ++ I? I is not defined. Can we do I equals whatever? No. That works in Bash, not here. Now, I think this might be the best we can do for now, so we're going to go ahead and submit that. $885th place. Went down 115. Yeah, with Code Golf, assuming that you don't know, or you can't see any major like places to remove characters, yeah, I think you'll end up having to shave off just 1 or 2 characters at a time. Can you wrap the prints with that? I wonder if you could. Maybe. I'm not sure. Oh, hold on. So I guess, yeah, that would save maybe a character. Or a few more characters. If we do this, so we print that, which means we can get rid of these ones, and then maybe we can do this, because we need to make sure that we have this in an expression. But that didn't actually save us anything, because we were at 65 before. Commas pop returns and jest. So the commas would be a... the commas here are... what do you call it? If you didn't have this, then this would actually be the first argument to print, the second argument to print, third argument to print, which is not what you want. So we need to have the precedence there. So now this is one expression, second expression, third expression, And then this entire thing is an expression that returns the value of the last expression. Which in this case is the value of r. Can you do this? Yes. That doesn't really save us anything though. Also, I didn't say hi. Hello, Lucas TA. Yeah, I think 65 is probably where we're at right now. We have 9 characters to shave, but I don't know where these 9 characters come from. Because can we do anything with this buzz or the fizz? Don't think so. This feels like it can be optimized, but I don't know how. Especially considering that these have to happen first. Right? Because our other alternative, our alternate solution uses fizz buzz, checking first for 15 with modulo 15, but that requires having both fizz and buzz repeated, so you probably don't want that. Some logic operator math magic. So it would have been nice if you could do this, but you can't. Not without adding parentheses here because of how JavaScript parsing works. So the best way I've found so far is to use a ternary for that. We'll maybe come back to this. But I don't know. I don't know if we have any. I don't have any other options yet. So I'm gonna go to. Actually, let's have a look at Rosetta Code because they do have links here. They do allow you to look at other solutions. Or at least like. Because the point here is not necessarily to solve the problem, but to solve the problem in as few characters as possible. So, looking at other people's code in non-golf form is not, strictly speaking, cheating. Oh. No, that's not gonna help. Because we, that's, this is quite the, okay, maybe don't do that. Although this is interesting. That's gonna be too many characters though. Very tersely. Can we do something with this? Is this something that we can do? I feel like this is maybe what everyone else is doing. So let's try this. Let's golf this. ft equals JavaScript. So we had earlier here a box catalog min. So we add in our solution here this 101, and then we got rid of this here. This turns out to be print. We can turn this into a 0 because it doesn't matter. Actually, no, it does matter. It actually matters in this case. So it turns out this is 58 characters, which is somehow fewer than our 65 characters from earlier. because we got rid of this. We got rid of 5 characters at the beginning. And then we only added 1 more character for these ternaries. And then we have this. Okay, interesting. But this is still 59 characters, 58 characters. How do you get down to 56? What can you get rid of to get to 56? Okay, well we can at least, oh, that doesn't even work, okay. What am I missing? 101. Right, because we had that as ++I. So, how do we shave off 2 characters? This is where the hard part gets to. Because now we end up having to do some trickery with who knows what. I think 100 is probably our... It's a big-ish number, but if we break it down any further using math, we end up having to use more characters, so I don't think that's it. 0 is also fairly minimal. Plus. We have the option of doing a string templates, but I think that actually uses more characters, so that's no good. Well, we might actually be stuck at 58 then. And what else do we have here? More functional style without mutations. Nope. ES6. Do we have anything else here? Why do you have so much code for FizzBuzz? Why are you doing array.from? What? Actually, no, this kind of makes sense. But that's too much for us. Test, yeah. Oh yeah, the test here. Functional implementation. Map. No, map is too much. Generic functions. What is all this stuff? Can we get rid of these? I don't think so. Because if you get rid of these, then that means this ends up being the expression, which is not what you want. So you do need this. I don't think you can change this into a single character pipe or line, because this turns it into a bitwise OR, and that's not. This ends up getting treated as 0, I think, and then we end up with always printing out I. In Java, if you divide int, do you drop the decimal? Yes. So int or a... Hold on. Is that correct? I haven't worked with Java in a while. I think if you divide an int by an int, you do get an int back, which means it truncates and you don't have anything after the decimal point. It doesn't round, it just chops it off. Oh, JavaScript. JavaScript, you get a... I was gonna say float, which is not entirely incorrect, but it does give you, say, like 5 divided by 2 is 2.5, so it does not truncate. Yeah, I don't see how we get past 58 characters here. Just one. Instead of two. But where would you put that? So if you, well, okay, hold on. If you get rid of this, I don't think that's going to work because then this is treated as the expression. Because the ternary has much looser precedence than the plus. But same thing here, because the ternary has much looser precedence than plus, this ends up being the expression here. Type deduction, true characters. So we still need this. We still need this. We can't get rid of these because then this ends up being the expression. Hold on. This ends up being the condition for this ternary. Just one side of the plus. Yeah, so we can't have... The reason why we need both of these sets of parentheses is because the plus has a higher precedence than the ternaries. So if we get rid of, say, this one, and I'm gonna do this in here, we run that, that's gonna fail, because what happens is, if I is a multiple of 3, then it does this. It's fizz plus that. So we only get here if we're in a multiple of 3. But if we do it the other way, if we do it with the other one, this here, and what this says is that it's either an empty string or fizz, and then concatenated with the modulo of I on 5. And then that is treated as truthy or falsy for this condition here, which means we either get only an empty string or buzz. So we can run that and see. We only ever get, apparently, the empty string. And now we get rid of both of them, then this gets parsed as a modulo of 3. So if it's not a multiple of 3, then we get the empty string. Otherwise, we evaluate this whole thing here. It's fizz plus the modulo of I on 5, which is always going to be truthy, so we get an empty string for all of them. Actually, that doesn't make any sense. We get the empty string for all of them. Why do we not get I? Interesting. In any case, it doesn't work. So I don't know how we shave off 2 characters. Oh wait, yeah. I don't know how we shave off 2 characters from here. But I think it must be the for loop. How do we shave off characters from the for loop? Because the only other way I can think of is we turn this to a while loop. But we need to initialize I somehow. Which then ends up meaning that we actually end up with... we end up with more characters even. So I think 4 might be our minimal, because we can't have, we can't get rid of, syntactically we can't get rid of this. It has to have actually, can we? I wonder if we can. do this. I don't think that's going to run because that's a syntax error. Yeah, that's what I thought. Maybe swapping the cases around, like this at the end. So the reason why you can't swap this around is because, so if you do I here, this will always, so the Boolean OR is short circuiting. I will always be truthy because we start at 1. Which means we'll always end up printing I and never getting to the rest of it. So the way this works is that this will end up being empty if it is neither multiple of 3 or 5. And then so you end up with an empty string, and an empty string is falsy, which means you fall back to the I here. Function. That's too many characters. There's no way. Surely not. So this prints that out. Go to OR, but we need to find some way of stopping. But also we can't. We have to loop this through to 100 times. And Y Combinator takes 38 characters, so that's not good. So A equals that. I wonder if you could. A is then I minus 1. I minus 1. That shaves off a character. It doesn't shave off a character. And we might be able to shave off a character anyway. 100. No. Okay, that's more. No way recursion will be the 4. You know, I don't know. I mean, in this case, apparently not. But considering that the syntax for an arrow function is pretty small, possible. But yeah, in this case, I don't think it does. I think we might want to come back to this because I don't see anything obvious here. We're gonna try a different puzzle. I actually haven't looked at too many of these. Some of them I kind of just, I don't want to say I gave up on them, but like Mahjong, for example, Mahjong. This is one, I didn't expect this to be here, but also two, you expect us to create a whole hand checker in apparently 219 bytes. Good luck. I'm not doing that one. Prime numbers, let's see what's in here. Prints all the prime numbers from 1 to 100 inclusive, each on their own line. We would use 5 classes for that. Yeah, actually, I've been thinking that I should maybe do a hand checker, or like implement a hand checker at some point. Just because it sounds like a nice exercise to do. I haven't done it yet. Okay, so maybe we can try this one. How do we know it's a prime number? If it is not a multiple of anything or of any other primes. Mahjong mentioned, yes, hello jelly code. Man, prime numbers is kind of annoying to work with though. Maybe not. Quine is a special one. I don't know how you quine in JavaScript in 25 bytes. So quine is quining is kind of hard, but a quine is where you have a program that outputs its own source code. I've written a quine before, not in JavaScript though. Kind of don't want to do that one. Is there something here that I've maybe already solved before in not golf? SI units. Let's see what this is. No, it's a lot of stuff. I don't want to do that. 390. This isn't golf anymore. Rule 110. What do we have? 73. United States. Nope. 12 Days of Christmas? 411. Nope. Keep going. If any of you have any puzzles here that you want me to solve, or at least take a look at, let me know. Something that isn't a couple hundred characters. Madman gave me some Madman puzzle. Yeah. Collats. You know what, this one? No, not this one. Copy is JSON. Nope. Not the Quine. Collats might be okay. This one is roughly equal to what we had before. At least the math puzzles are kind of straightforward, so I'm not too concerned about the math ones. So the Collatz conjecture states that for any positive integer n, 300 lines of obscure JS. Yeah, that's kind of unwieldy to work with. That's not even lines, that's 300 characters. So that's even less readable. For any positive integer n, it will eventually reach 1 by repeatedly applying the following procedure. If n is even, divide by 2. If n is odd, multiply by 3 and add 1. Number of steps needed for n to reach 1 is called its stopping time. For example, the stopping time of n is 6. Print the stopping times of all the numbers from 1 to 1000 inclusive, each on their own line. We can cheat. We have the Rosetta code. Let's go to JavaScript. Because we're not here to solve problems, we're here to golf. But these are all still looking fairly long. Well, why do you do this? This is not good. No, whatever. I'm actually thinking we maybe do this in Bash. So we have echo as our prints, or printf. We have loops there, accessing args. Because in Bash, it's very easy to loop through 1000 characters. What did you say here? Yeah, very easy to loop through 1000 characters, or 1000 numbers here. 1 to 1000. Now, is this any shorter than for I equals 0, I is less than or equal to 1001 I plus plus. Yeah, okay. Yeah, okay. For I in 1 to 1000 do, then we gotta figure out how to calculate this. We do need a space there. So if n is even, then divide by 2. If n is odd, multiply by 3, and then add 1. We can do... So let's call this n, just for consistency. If n is greater than 2, or if n is divisible by 2, then we multiply by 3 and then add 1. We may want to consider a function. So if we call a function c, where we do $1, because this actually has to be, or n equals $1. We'll start there. I wonder if that actually saves anything. Well, we can start somewhere. So if n equals $1, and then we have n is even, or we do c of, no, this isn't going to work. Okay, let's just write this out for now. If that, so if n is odd, then we multiply by 3 and then add 1. C of n times 3 plus 1. Else we have c of n divided by 2. So for sure we should be able to pare this down by quite a lot. Let's expand this a little bit just to see where we're at. And see if we can optimize the structure a little bit before we optimize all the characters. If we get down to, not this one. We get down to 1. So if n is equal to 1, I think you do single equals actually. Can you? N equals 1. Does this work? No, that actually does do it in assignment, so we can't do that. So if n is equal to 1, that has to be double equals. Then we print, or we echo some sort of counter that we have. I guess we can call that, let's call that S. And then we have S++. If you do a plus plus on a number that doesn't exist, or rather a variable that doesn't exist, then I think it'll just increment it. So for example, C doesn't exist. We do C++. We get 0. We get 0. Interesting. Ah. Okay, but we need. Oh, we actually need this up here. Because if it isn't 1, that'll be 0. Oh, but that's not going to work. Print all the solving times for numbers 1 to 1000 exclusive, so that actually has to be up here, because S++ to start with is going to be 0. That's not true either. It's plus C. So that's actually 1, 2, 3. Yeah, the whole increment decrement thing, that's not it. Ah. I wonder if this is going to be easier in JavaScript. Because looping is really easy. But doing anything else in Bash is can be a bit of a pain. So we have this. But actually, come to think of it, this doesn't all need to be on one line, because new lines and semicolons are all the same in terms of number of characters. So we're gonna actually just do this. Ah, but then you have to do that. Can you do... Is it going to save any more time if we save any more characters if we do this instead? If n equals 1 and echo and return. Possibly. But then the problem is we have no way of doing this one, so maybe we do need this. Maybe we do need that. Do CN and I'm done. This is turning out to be a lot of characters and I don't like it. Not to mention that this isn't working. I think this is still preferable. Actually, we don't need this. We don't need that because we can just get n from the environment. So we don't need that either. Where else can we cut corners? That is probably it. Unless, hold on. Does Wikipedia have any... This is the wrong one. I'm gonna move this out of the way. I was thinking if there was a way to calculate the number of steps, but I then remembered that the coalesce conjecture has not been proven. So we actually don't have a way of calculating the step number. I think. Yeah, I'm pretty sure we don't have a way of doing that. But And we can at least... Oh. That would save a character, but we can't do that. Because then this isolates the environment. We can't do that. Okay. We're not doing that. We're going to submit this. This is a ton of characters, and I don't like it. This is 118 characters. Is this true? Is this right? I think this might be right. Okay. Well, let's run it, and if it works, it works. Probably not going to work because this is the first time running it. Segmentation fault. Very nice. Also, it doesn't work anyway because the S++ is we need S equals 0. Equals -1, but then that's one more character than we need. But also seg fault because recursion. Can't do that. So what if we turn this into a while loop? That's probably better. And what if we turn this into a while loop? So while let's do that stuff over here. So while n not equal to 1, or until I actually have the until loop around. So until n is equal to 1, then we do all this stuff. Do echo s break. Actually, no. Until n equals 1, we don't need to do this. Then we can just echo s afterwards. Echo s down here. So until n equals 1, if this, then n equals this, else n equal this. I think this is a thing that we can do. Yes, okay. Can we do a plus plus somewhere? No, that's probably not. So if n is this, then we do this, else we do that. We do this. We echo s. Done. Okay, so this goes to here. That's not right. So for let's make this a little bit easier to read. Do if, then else, and if. Done. This goes up for the until loop. And until and while have both the same number of characters, so this should be fine. And we need to do s++ somewhere. S equals 0. S++ here. Can I do that? think I can. Syntax error. Okay, can we do comma? Okay, we can do a comma. So that saves us a pair of parentheses here. So this gets us down to 111, 110, which is still more than half of these people here. But at least it works. At least it works. Can we pare down any more? Surely. So s equals 0, I wonder if we can not. I wonder if we do this, echo the empty, hold on, so if we do, yeah, echo y doesn't exist. Does that print 0? Oh, it does print 0. That prints 0, but that's more than 3 characters, so that doesn't actually help. Because doing it like this, that's 1, 2, 3, 4, 5 extra characters, where this is just 3 extra characters. Or I guess 4. So we actually don't gain anything from that one. And this is probably still the way to go. Did I see the Wikipedia? Is there anything in here that I should be looking at specifically? For loops allow you to use oh. Since when do for loops allow the use of braces? Hold up. When was this a thing? I know you can do this, the arithmetic C style for loop, but I was not aware that you could do for like that. Why does my IME keep doing? Actually, hold on. We can just test this out here. For f in 1 to 10, say. Echo n. No way. But also doesn't look right. Oh, because it's F. When was this a thing? I don't remember this being a thing. I have to look that up. Bash manual. Is this a syntax? Well, I mean, it's got to be some sort of syntax. There's got to be some sort of syntax extension, because I don't remember this at all. But good to know. That actually saves us a bunch of characters, which means we can do this. Or at least I think we can do that. Can we actually get rid of that? No. So you do still need the space there. Which means we can use that. And then we can use this. Does that also work for the until loop? Until n is equal to, or I guess until n. Ooh, until n. Because then that would be while n is not 0. While n, do this, s++, because we can still no, that doesn't make any sense. We can't do that. But anyway, until n is equal to 0, so let's say n is equal to 5 here, or 4, doesn't matter. Then we do this. Do I have this wrong? Right, because I still need the space there. Something's still off. Maybe it doesn't work with until. Or while loops. Which is very weird. Why would it allow it for loops but not while loops? Okay. That brings us down to 106 characters. Well, something's still wrong though. All zeros. Because okay. Why doesn't this work? Can we get down even further? Because I think there's a syntax error. Why it works for 4, who knows? And while and until are the same, so that's fine. And then we echo S. So for n in this loop here, I found that tip there, code ball. Let me have a look at this. For loops allow you to use braces instead of do done. Undocumented works every version of Run 2 for Legacy. Goes back to the Born shell, really. Ah. I guess it must be really old syntax then. For arithmetic expansions, use this instead of that. Okay, yes, I do remember this being an old version of arithmetics. In arithmetic expansions, don't use this. And it's performed on indexed array subscripts, don't use that either. Don't use that. Define a function. You absolutely need a space for code, simple after it. Yeah, so, and then if you use it, if you turn this into a subshell, which I tried to do earlier, then realized I couldn't because I was using variables from the environment. Let me define as follows. Yeah, because then you can just use this. I don't know. So obviously there are solutions that go down even further than this. So then the question is, can we get rid of the if-else here? Because that is eating up a ton of characters. You know what, maybe. 529, welcome in, good evening. John, actually, I wonder if we could. The problem with this is that you don't have a proper ternary in arithmetic expressions. Or in Bash at all. I just finished building the first half New Block City with my odds. Do I remember what that looks like? But anyway, congrats. Seems like a big build. Ternary operator is just short form of if then else. This is way more characters than we need. So that's not gonna work. This is not gonna work too. Oh, actually, wait, it might. Hold on, this might. As long as we don't end up at 0. Do we ever end up at 0? I don't think we ever end up at 0. Because if you ever end up at 0, then you stop being able to do anything. So I think we can assume that this is always going to be positive. Which means we can do this. I think. Syntax error near unexpected token. Haha, attempted assignment to non-variable. We might still need spaces there. Spaces are important. They're not that important. This might still be okay. We can get down to 84 characters. Timeouts. No such file directory. Still fewer characters than our if else. Save 14 bytes, which is good. That's good. Now the question is then, can we somehow not do that? Do we care about errors? Because we can just do this. And then not have it do any, like, does standard error mean anything here? Command not found? Do you care? Actually, I think you do care. You probably do care a little bit. But also this is wrong anyway. Because on the ones that fail... yes, because then this doesn't work. Okay, so we can do this. And then leave this one as errors because it doesn't matter. I don't care that I don't care about errors. So that's the thing about code golf. Usually you don't care about errors as long as you get the right output. So save 1 byte there. But we're still about 40-ish 40-ish bytes. I think, if I can math, 50-ish bytes. This rounds up to 50, this rounds up down to 90. Yeah, 40-ish bytes. We can still shave off a bunch of stuff. Can we do this? And then maybe get rid of this, which doesn't work because S plus here ends up being 1 to start with, so that's not going to work. Access Miriam, welcome in. Oh. Meru. Yes. Something like that. I hope that was okay. Yeah, we're just doing some code golf here, trying to pare down this bash solution. Which I don't think is going to work here. So we still need this S equals 0. But it does mean that we can get rid of this here. And we can get rid of this here. So it brings us down to 89 characters. Assuming that we can use subshells here. And we cannot. We cannot. Okay, so we're stuck with this. Does this actually not work? Attempted assignment to non-variable. Token is that. Is this. N is a variable for sure. But I think the problem is that it needs to be this. Is that how you do this? Oh hey. I don't think we saved anything though. Because our original solution was 89 characters. Or no, our original solution was 91. Okay, so we shaved off one. We might be able to shave off another if we do this here. So n divided by equals 2. And then we can get rid of this. We do it this way. We shave off another one. Okay, so now that we're shaving off single characters, I think that we might we might be hitting our limit on how far we can get this without a drastically different solution. Like, for example, we change this for n in whatever to until n plus plus n less than 1001. Oh, but then we have to do the do done thing, which is going to add to our count, so we can't do this. Also, it doesn't save us anything anyway. Yeah, I think 88. Yeah, I think 88 might be as far as we get for this one. Because I don't see anything else. No, not bad. 49 is still pretty crazy. We got all here. We are here. Better than 42% of golfers. Which, hey, you know, top 20 is not too bad. I guess nobody does anything in Bash, I guess. Which makes sense. But 3,000 bytes. Did they just grab this from Rosetta Code? Oh, actually, that's a good question. What do we have in Rosetta Code? A Born Shell. Or Bash here. Max Len. Show number less than 100,000. So this is no good. We do not want to be doing this. Oh, using arrays. No, that's just dynamic programming. That's not gonna. It's not gonna help us here. Oh. Hold up. What's this? What's it? Oh no, that's just test. Never mind. This is a test to see if it is odd. Otherwise even. Okay. So that's not good. This doesn't give us anything. See if the JavaScript one has any hints that we can use. Or anything else for that matter. I don't think so. I might have ideas if I hadn't tuned in so late and hungry. Yeah, there's no worries. So far we've gone through FizzBuzz and the Collat's conjecture. I think we might leave this one here and move on to something else. Now the question is what next to go to. ASCII table. Print the following hex ASCII table taken from 7 ASCII. 90 characters, I'm not doing that one. I'm trying to go for something that isn't so large in terms of characters. Because then it actually feels like golfing and not just a problem that you're trying to minimize the number of characters. That makes sense. So far we've been doing... Well, what did FizzBuzz count as? FizzBuzz counted as counting. Collat also counted as counting. I think these counting ones are pretty good, but also I don't want to do all counters today. I'm not writing a VF interpreter in 120 characters. That's 400 characters. No, thank you. CSS colors. 650. Nope. Did it any better in JavaScript? Probably not. Yeah, nope. This one sounds expensive too. Nope. Factorials. Print the factorization of one. How would you even do that? Fractions. For each fraction argument, A over B, reduce it to its simplest form. That requires math, which I think you do get here. But also 63 bytes. But everyone seems to be getting 63 bytes, so maybe this isn't too bad. Simplifying, reducing fractions, dividing the numerator and denominator by a fraction. Also, I definitely don't want to do this in Bash, because... Oh, I mean, apparently Bash is a lot easier to get down Or maybe easy is not quite the right word there. But the thing with bash is that you can only work with integers. Dividing numerator and denominator by a fraction by the same non-zero number yields an equivalent fraction. Do not share any factor greater than 1. Fraction is already reduced to lowest terms. Euclidean algorithm. Yes, I do remember this. Kinda don't want to bother reading all this though. Maybe something else. ISBN. Modulo 11. That's 74 characters. Okay, I think this one might be okay. So then the question is, where do we get this from? Do we get this from the arguments? Calculate the check digit for these incomplete. Oh, incomplete. Well, okay, that's fine. So if I assume the argument's 0, just so we see what this. Oh, there's a ton of arguments. There's a ton of arguments. Okay, so this is our test case then. And then what happens is we loop through all the arguments. For arg of args, that is one way to do it. The arguments, however, is not an array, so you do have to make it into an array. And I think probably turning into this is probably going to save us more characters. So doing a map on it. Where we do... Actually, I wonder if a map is going to save us any characters. Because then you end up with this. Whereas for A of arguments is only this. Yeah, we actually don't save the we don't save anything from doing that. Okay, so we do this instead. For A of arguments, then we do for print A plus something. Can we do this all in one single expression? A got replaced. Well, let's start with replace all this with nothing. And then splits. And this is going to be better than split. I guess you can map it. So what I'm trying to do here is that try to split all the characters and ignore the ones that are hyphens. But it might actually be better to split this first, and then ignore the hyphen afterwards. We take CI here, But then it's module 11. Hold on. I think we might have to write this out in an editor. Strict equality seems wasteful. Yes, you are right. Alright, we're gonna do it. We're gonna do it in here so that we can JavaScript. So we can type this out in a form where we can actually read it. This is how we split the characters into an array. And then we do either a map or we do another for. What if we do for? So if we do for C A, do we even need that? For A of this, console log A. Oh, even better. We don't need to do this because it takes an iterator, and strings are already iterators. Does the site give you prints? Yes, it does. Taking several minutes to understand why I was getting a print dialog. Is there a window.print? Is that a thing? Oh, wait, there is. Ah. Oh, it's new. I see. Well, apparently it's been around for a while in a bunch of browsers, but it's only been standardized recently. What was holding it up? I guess the mobile versions? Feature works across latest devices and browser versions, I see. Okay. Minus 10a equals a mod 11. Yes. Think. I'll look at this because I remember calculating ISBNs before. Each of the first 9 digits of the 10 digits ISBN, excluding the check digit itself, is multiplied by its integer weight descending from 10 to 2, and the sum of these 9 products found. The value of the check digit is simply the one number between 0 and 10, which, when added to the sum, means the total is a multiple of 11. Why is it negative? So actually we can probably get rid of it. We can't. So for C of A, so this is for every character here. Let's do that. For C of A, then we do C is equal to hyphen or return, continue. Oh, that's a lot of characters. Whatever. We'll continue with that. If that ends up being the thing, then yeah, whatever. So if C is a hyphen, then we continue because we want to skip those ones. Otherwise, we do C So the next character is then, we need some sort of counter I equals 0, where C times, or I equals 10, I guess. C times I we need some sort of counter here, accumulator. M minus equals C times I. So I think at the end it'd be, so hold on, if you take the modulo of something like -5, but then you add 11 to it, then you end up with that. You got a positive number. Check digits means it's multiple of 10. Okay, correct. So then it is 2. So then that means that we can do something like this. M equals M plus 11 modulo 11, something like that. But then we can do, no, that doesn't make any sense, because we can go all the way down and still be very, very negative and not have plus 11 be. No, that doesn't work either. Okay, so modulo 11 we get something negative, which then we can add potentially 11 too, but then we need a special case when it's 0. Well, in any case, well, we'll start with that, and then we need to do, if M is 10, I slept very poorly, but it's too late for a nap now. Yeah, I understand that. So I mean, either you take you sleep now and then just wake up really early tomorrow, or I guess you just wait it out until bedtime. I don't know if this stream is the best one for that though, but maybe if you rack your brain against the solutions, maybe something will happen. Okay. So I think eventually we end up with something like this. Except M, if M is equal to 10, then M or X, otherwise M. But in parentheses. We still need to normalize this though. JavaScript, normalize modulo positive. I swear there was something here. Only slightly engage with the programming chill vibes far better than simulating. Okay. So the remainder here, because this is going to be negative, with the negative dividend. What happens if we do negative 11? No, it's still negative. Yeah, as long as any of them are negative. Actually, no, it only matters if this is negative. So that's not going to work. So then the question is, do we save this to a variable? If we use it a bunch. So we can at least, we can do this, I think. So we can collapse that into that, which means we don't need this anymore. We don't need that anymore. We can collapse these into here. I equals 10, m is equal to 0, because we need that to be here. And then we need alright. Give me ISBN. I don't think I showed anything off in there. That should be fine. Or we don't do that, and we do the addition. We do the addition, so I is equal to 0. I equals m equals 0, so we can now reset everything to 0. And then that means that... Oh, I see why they're doing negatives. I see why they're doing negatives. It's because you want it to be subtracted from 11. Because if you have a negative one, then you have something that's negative, and then you just take the positive of that, and then you get what you need to do what you need to add to get to 11. Is that right? No. So you still need the this. Okay, 5 plus 6 is 11. So from negative 5... Oh, that's not right either. Hold up. The check digit is computed as this, modulo 11. Which is correct. I think... To get to 11... So if you are at 130, right? 130, 130 is modulo 9, or is 9 modulo 11. So it is negative 2. Okay, no, so that's correct. So you actually do want this to be that. Which means this is minus 10. Or minus 11. No, minus 10. M is 0. This is correct. So then M modulo 11, or M equals M modulo 11 times negative 1. Is there a better way to do that? I don't know, there might be. You save a character there. readability, we can do this. We can also save a character here. Can we save characters at all here? I don't think so. Because we can turn, while we can turn this into an expression, we can't turn the for loop into an expression. So if C is not equal to hyphen, then we do this, which I think is still okay. And then M equals this, and then we print it. Which already has the dash at the end, so that should be fine. Okay, so let's give this a shot and see where we're at. 91 characters, which is, you know what, fairly close to where everyone else is. But this is wrong. Mod 11 is the same as A plus 2 to mod 11. A plus 2B plus 3C. Are you sure? Does that work? Invalid left-hand side of assignment. Oh right, because we saw this earlier. We can't do that. This needs to be wrapped in a thing. Oh, but this is wrong anyway. Aha. Only the zeros are correct. Otherwise, we are off by or negative here. We gotta flip something. Okay, so if you're saying that works, then what we can do is we can have I equals n equals 0. And then I plus plus here. And we have n plus that equals that. No, but that doesn't work either, because I needs to be 1 for that to work. So I can be 1 here. That. And then that means we don't need to multiply by a negative 1. Hey, look at that. I don't know if I want to think about the mathematics of why that works. But okay. Thanks for the tip there. So 87 characters here. Can we get this down to even more? Or even fewer? Because there's surely something that we can do with this. Okay, actually no, we can do this now. I'm a mathematician at work. Can we do something with this? Well, there might be. Hold up. How many characters is this? I probably is going to be more than I would like. Yeah, that's definitely more. Okay, we can't do that. No, of course it's the same thing too. Okay, sure. That's no good. Can we somehow turn this into an expression? Doesn't make sense to map this. So we had A here, dot map B to this, which is actually more than the for loop, so we can't do that. Okay. How do you get down to 74? We're about we're about 12 characters away. We have an extra space that we don't need. Let's shave off 1. We're still 11 characters away. Hate this. Oh man, okay. Okay, we shave off 1 character here. So this here works because if M is 10, and then we subtract 10 and it ends up being 0. 0 is falsy. So we go down to 84 bytes. Is there any case where the answer is 0? Yes. There are cases where it can be 0. We have some examples here. Like the second one is 0 here. Does that... I don't know if that helps us in any way though. Because if we do any sort of conditional for checking to see if it's 0, then that actually uses more characters because then we do branching. Anything we do unconditional would be where we apply something to everything, then I think that saves characters. It's unfortunate that we have to use arguments like this stuff. So I assume the way this is implemented is that this is wrapped in a function, and we get the function arguments using arguments. And print is some sort of global function that they've defined. I was thinking maybe this, but I don't think that actually works, because you still have the possibility of your last addition being over 11, so you still need to clamp everything down afterwards. Does it make sense to use I at all? Good question. Well, you need some sort of counter to go up from 1, right? Or from 0? Or I guess 1. But I don't see anything else where we can use as a counter. Because we can't reuse M. Because M is holding something important. It needs to be persistent across the loop, so we can't use C. Now, one thing we could do, I guess, but we already determined that this actually takes up more. So you could do a map where you take C and an I, like that. But that is way more than the for loop. Even I think accounting for this. So I think this might be the. We've already shaved off a bunch of stuff, and I think this might be it. I think this might be it. I don't know how to get to 74. We have about 10 bytes to get rid of. I wonder if this is any easier in Bash, actually. But no, actually this is kind of annoying in Bash, so maybe not. Okay, well 84 characters I think is pretty decent for where we're at. Somehow people managed to get down to 74, 75 really easily. I don't know how. But hey, you know, top 50 is not too bad. Okay, we'll leave that one there. Their newest one, Capricorn numbers. I kind of don't want to do. So we'll maybe not do that one. How are we for time? It's been 2 hours. I'll go on for a little bit longer. Natural logarithm of 2. Print the first 1,000 digits of ln 2. So JavaScript does actually have math.ln2. But that only has a certain number of precision, certain amount of precision. So that's unsuitable. So then I was thinking maybe we do the continued fraction form, where we take this, shove it into some sort of array in here. I don't know how much of this we need to get to 30 or 1,000 decimal digits, but maybe we need all of them. Yeah, let's reverse all this. No, that's not right. I need tack. Like that. Okay. But this is 165 characters, and they're all doing it with 53. So that can't be right either. Actually, maybe. We do then a reduce. Reduce of I or AI to I plus 1 over A is how this goes. So continued fraction is something in the form of this. A simple continued fraction. Where you have continued fractions have a numerator of 1, but it all of the numbers here, so A0, A1, A2, all the way down to AN, is this. And I think this is probably fine. Yeah, and we don't need to start with a. I don't think we need to start with 0. If we need it, we can start with the first one there. So this is fine. We just need to know how many decimal points this is. Come on. That doesn't give us enough precision. How do you expand this to be... I will then have to assume that we end up having to multiply something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Times 10 to the 16. Ten to the 17, 18, 19. We don't have the precision for this. Well, that sucks. So how do you print this if we don't have the precision for it? Is a unique real number argument such that the exponential function equals 2. It is also given by the alternating harmonic series. Wait a minute. Truncated 30 decimal points. How are you all doing this with 50 characters? 53 characters. What? All these formulas here, but if you work with them as... Because there's no such thing as a big float in JavaScript. You have a big int, but you don't have arbitrary precision floats. Or at least I don't think you do. Not unless you use them as strings. Floating point guides. Mr. E, welcome in. What is code golf? It is a programming exercise in which you try to solve a problem with as few characters as possible. So you're definitely not going for readability here. You're going for the smallest that you can. What was the other one that we did? So yeah, for example, this was our solution for FizzBuzz. There is some way to shave down to 2 more characters. I don't know where that is yet. But it's somewhere in there. And the other one we did... I think it was Colats. We did this one in Bash. And so it'll look like this. And we have... What is 88 minus 49? 40 something? 39 something? But yeah, this one can apparently get pared down by a ton, but I don't know how. But it's definitely out there. And then this, I don't even know where to begin. Because we don't have... Wait, well, what did I type for that? Okay, whatever. Use a special decimal data type. We don't have one of those. You want to see all extra decimal places, so we format this. You don't work with integers, but you can't do that. How do we have big decimal? We don't have big decimal. Can you use any language? You can use any language that's listed here. There are a bunch of different languages. Some of them are crazy, like SED and tech. Because apparently, you know, you can somehow program in them. But yeah, you don't have big decimal in JavaScript though. Not natively. Oh, dig decimal. Python. So easy. Yeah, Python probably has the correct data types for this. Let's try this one that you had mentioned. Starting from A0, each term of the sequence is an equals an minus 1 minus n, but only if an is greater than 0 and is not previously generated. Oh, it sounds like we're getting dynamic programming. How do you get to 43 in Bash? Of course, Java's going to be a lot. Thank you. How is anyone doing this in tech? No, I don't understand. I mean, yeah, tech is Turing complete, apparently. So it is possible to do stuff. Okay, let's go back to JavaScript. Oh wait, what do we have? So this is starting from A0 equals 0, each term of the sequence is an, but only if an is greater than 0 and it has not previously been generated. In the case the condition doesn't hold, then an is equal to that. Plus n. Okay. Well, we can cheat because it does have a Rosetta code linked to it, so we can just take whatever solution that has. But programming this normally, you'd have something like function A. Man, pattern matching would have been nice here. And then we'd have, say, an array. Call that D. A of n, in which case we have if n in D No, we still do want this if here. If n and d, then we have d at n is equal to a of n minus or plus n. All right. Yeah. A of n minus 1 plus n. It's only if we haven't generated it already. Otherwise, d at n but only if a and n is 0 and not previously generated. In the case that a condition doesn't hold, which condition then? Let's go to Wikipedia here. So if it is 0, then n equals 0. If a of n minus 1 or is equal to a of n minus 1 minus n, if a n minus 1 and minus n is greater than 0 and is not already in the sequence. Oh, okay. That's what you mean by not already generated. So this is not correct. we're not looking for performance here, so we don't actually care. We don't care all that much. So we say then that we generate this first then. So we call that M. Do minus N. So M equals A, the sequence here, minus M. But we're starting from... Okay, so we're starting from 0. Starting from 0. Yeah, okay, we're starting from 0. Which means we can actually say... save a little bit of time here. And have this be that. Dynamic programming and all that. And we say if M or D includes M, then if D includes M, then D at N is equal to this. Otherwise, D at N otherwise it is M. Okay. Then we don't need this. M is greater than 0 and not includes this, which we can actually negate. But I don't think that changes I don't think that changes anything. In terms of character count, because if we negate this, and that means this has to be less than or equal to, then we just get rid of this, and this becomes an OR. Which doesn't help. But what I think does help is if we turn this into a... we turn that into a bitwise operator, which I think still works because it turns the booleans, these two booleans, into numbers. So this should work as expected. So that should be fine. And then we don't need this function here. Which means then we can do for I equals 0 or n equals 0, n plus plus less than $250. And I think that still saves us a character. And then we can do this. And we can do this. And I think that is probably going to work. I expect this to fail the first time. D is not defined, because we got rid of D. But then we have a problem of what happens if n is 0? Then I guess we can do this. Which I think is still fewer characters than if we were to try the alternative. A is not defined. because it's actually n minus 1. I can't do the n minus minus. Actually, that doesn't even change anything, so that's fine. Okay, and we still fail because we get NaN. From what? Right, because of this. Because at 0, we get that. It's not quite correct either. So starting from A0 at 0, or A at 0 is 0. Each turn sequence is this, but only if A is not equal to 0, or is greater than 0 and not previously been generated. Okay, we're gonna break this down again. So print if n, we do this whole stuff. Otherwise, we do 0 here, and then we do that. Considering a dose of caffeine. Well, good luck if you do. I don't know how much that's gonna mess you up, depending on how much time you have to wait until you usually go to sleep. I'm personally not one to consume too much caffeine. I'm not a coffee drinker, not a regular tea drinker either. I will have coffee in food as a flavoring. I will have tea whenever I feel like it, and can be bothered to clean the teapot. But yeah, otherwise I don't really I don't have any dependence on caffeine. Yeah, if you need it, then go for it. Well, you see, it's messing has already been done. Fair enough. Fair enough. So m equals d. So this we need to calculate because we need to know if that's greater than 0 and it does not include sequence. It is includes, right? Array.prototype.includes. Yeah, okay, so that's correct. Ah, but this A is not a thing anymore, so that's not good either. Why is that still there? But then that means it never ran anyway. Okay. So let's turn this into a Boolean. So I don't think that actually matters. Okay, so if it never got here in the first place, that's a little bit concerning. Maybe we do this instead of doing this here. D at n equals 0. Which is still the same thing though. And it actually just uses more characters, so we know. Am I missing something? I mean, clearly I'm missing something. 2, 10. Yeah, why am I getting negatives? So if m is equal to this, well no, so m is this. And then you have d at n. So we start with 0. I guess we go 1 actually. So d at 1. Because this ends up being 0, which we initialize here. Minus n, so that's -1. Do I have to... I think I might have to do this way. Which means it might have been better to do it the other way. Okay. Apparently that was not it. Okay, so it does have correct precedence then. So if m is greater than 0, which it is not, then we go for m. Oh no, okay, so this is backwards. I need to do m here and then do that there. Okay. So this should pass. No, it does not. What changed? I have an extra one. Off by 1 error. Okay, so this should pass. How do you get to 51? I think there's definitely a bit of inefficiency over here. There's inefficiency here because we can just not do that. We don't start from 0, we start from 1. Because we already pre-fill the first one. Hello? How many characters did we get earlier? 82. Okay, so that's not gonna work. What does print return? Undefined. Can I use that to my advantage? I don't think so. Actually, maybe. Oh, this is awful. Oh, this is awful. I think I've used more characters. That's not gonna work. Okay, so how do we print 0 first and then print everything else? So this actually, okay, so how expensive is it? 1, 2, 3, 4, 5, 6. This is currently 6 characters. And anything else, so let's say p equals print one, 2, 3, 4, 5, 6 already. 7 even. But then we cut down on this here. But then we'd end up having to do that anyway, so that's not gonna fly. Too bad JavaScript references aren't a thing. Because then we can just put this in, we can just make that a reference. Or a pointer or something. Yeah, I don't see anything else we can shave down from 82. But apparently they're all doing it at 51, so there's got to be... So there's either... So includes here. Includes. Hold up. Hold up. Can we take a different approach? So instead of just one array, what if we do some sort of mapping? Let's say t equals some sort of array or some sort of object here. We do say something like this. Can we get rid of t like that? So t here is going to be an object that contains an array, or contains one for every value, or is a mapping from values to key, or to say true or 1. If it exists in this object as a key, then that means that we've generated it before. Then that also implies that we need to do that. Which unfortunately there's no pass-through. So I want to assign that as a key. And I think that's even more than includes. JavaScript array includes value. Other than includes, because I know that's a thing already. Oh, some. No, but that requires something else. Requires a anonymous function, an arrow function, so that's 30 more characters. index of 1, 2, 3, 4, 5, 6, 7. But then you end up having to check if it's -1, 2, 3, 4, 5, 6, 7, 8. I think includes is 8 characters, index of is 7. That's not gonna work. Find. Ooh, find. But find takes find takes an arrow function, which I don't think is going to be any shorter. So includes find yeah, that's definitely longer. That's not gonna work. Or we do this, but it's still longer, so that's not gonna work. Yeah, I think includes is probably the way to go here. Yep, okay. Then the other question is there a way we can deal with the loop here? I don't think so. So just double checking here. If we do this, as opposed to n equals 250, x n equals 250, while n minus minus, which is at worst or at best the same length, so that's not going to work. Yeah. You know, I think for now this is probably... Oh, hold up. We can do this. I don't think that saves anything, though. What substitute are we trying to find for includes? Would searching a stringified version work? Yeah, I don't think we can do that, because then we'd, yeah, I don't think that would work. And this doesn't save any characters either. We just shifted some stuff over. It'd be nice if we didn't have to do -1. But we have to start at 0. Or if we don't start at 0, then we find a way to print 0 to begin with. And print 0 I think takes 8 characters or something. Whereas this is only 6. We wouldn't actually be saving anything if we printed 0 first. So I think 0 has to be part of it. What other ways can we get -1? Nothing that is fewer characters than this, I think. Does n++ less than 251 break somehow? Yes, I think we tried that earlier. But also, I don't see how that's that improves the count here. Yeah, I think you have an off by 1 error here. Yeah, and you still get 1 for the first iteration, yes. Oh, wait a minute, hold on. Can we do... We can do this. We get rid of all those. It brings us down to 79 characters. So this here works because if n is 0, then we don't execute any of this stuff over here. And instead this returns 0. So this should work. Or not. Left-hand side invalid in assignments. Because we still need to do this, unfortunately. But it shaves off the character, so that's good. Yeah, 1 character gone. It's well, I mean, when you're down at this level, it's definitely an achievement. How would you get rid of 40 or 30 characters though? If we get rid of 30 characters, that means that there's definitely something. There's some sort of shortcut here that you can do, like getting rid of this somehow. Oh, wait a minute, hold up. What am I doing? E equals D thing. Then we don't have to do it twice. Right? That would make sense. I think we save a couple of characters from there. We shave off 1 character. Alright. We're making progress. So D adds N. M is greater than 0. So we can get rid of this, turn it into this. Or we're supposed to be able to do that anyway. So if M is greater than 0, oh, no, we can't. We can't because it can be negative. So greater than 0 actually has a purpose here. I think this is definitely something that can be somehow removed. D equals array. Isn't that more characters? DM would be undefined. Wait, hold on. Yeah, so that was what I was trying earlier with the T thing. But the thing is, you would have to also set that. So one, because we're not creating a function and we're using dynamic programming here, we need an array to hold the previous values. Hold up, wait a minute. No, yeah, we need an array to hold the previous values. But then if we were to do that kind of optimization there, hold up, sets. I need a set includes. Set.has. Now the problem with set though, I think, is because you do have to use new. Let's double check that assumption. Can we create a set without having to use new? Requires new. This isn't gonna work. This isn't gonna work because we need to know what came in before. Sets are unordered. I mean, they're technically ordered here because if you call values on them, they go in an insertion order. The problem is, you can't get the last one that was inserted. So we'll actually end up using more characters that try to use a set. Which is too bad. Or do we care? Do we care? Because if we create a set immediately, is that going to be more than d.includes? Probably. New sets d.has m versus this. Yeah, that's definitely more. We can't do that. Surely there's a more efficient looping method. Okay. I think we can probably do this. Because we don't care about the first one. Abuse number keys in an object. I thought about that too, but you still have the same problem where you need to set it on the object for it to work. Does this work? Do you have to do it this way? I think you have to do it this way. Okay, this saves a bunch of characters. Okay, that saves 3. But that still requires 26 characters down. How do you get rid of that? We have this ternary here, which we have this as our expression. If that is true, then we do m. Otherwise, we do e plus n. D at n equals m, or d at n equals. Sorry, that's not correct. We do this assignment here if this, or whatever the output of this is. And we move this in. I don't think that actually helps. I don't think moving this inside of the for loop here helps, because we still need a comma for something. N equals 0, D equals array of 0, N is less than 251, E equals DN plus plus broken. I'm gonna give that a shot. That might save us a character. I put that in right. This needs to be 251. Gets us down to 76 characters. Something's wrong. I'm guessing this is an off by 1 error. This needs to be 250. Which kind of makes sense. Guys, alright, gonna save 1 byte. Thanks for the tip. Is that gonna work? I don't think so. Because I think that'll always end up being 0. Is there a better way to check if m is greater than 0? That's what I was thinking too. Like e is greater than n. Ooh, ooh, you have a point there. Because e is e minus n. Yeah, I think we might be able to mangle this in terms of math stuff, because I've also been thinking that m here is, or rather this here is just e plus 2n. But yeah, I think you're onto something. So I think if we turn this to e is greater than n. Alright. I don't think that saves us anything though, because we still need m for d includes. But I wonder if we would be able to get something here. Well, if we do, I'm not seeing it. However, okay, no, I was gonna say we can do this, but I don't think this actually saves us anything. We're still at 76. I think that would work, but it doesn't save us any characters. But what will save us characters is this. This is awful. Does it? Does it? Oh, it's cursed. But also apparently doesn't save us any characters, so it doesn't matter. Would have been nice though. Is there anything other? Is there anything else cursed like that we can exploit? I don't see anything. I don't think we can collapse this anymore. Yes we can, yes we can. We can do this. They shave off 2 characters. I don't think we can collapse 250 anymore. So D is equal to this, N is less than 250, and then we do this inside there. I don't think we can collapse this anymore. And we print this. Do we need E? I think we do. E minus N. E greater than N. Well, at least it all fits on one line now. That's nice. This still bothers me, because surely there's got to be some way we can cut down. I don't see anything though. Okay, I just noticed something. What do we have? We have M and then E plus N. Okay. Distance between each element of the sequence is also 1, 2, 3, 4. Yes and no. I mean, yes, the absolute distance between each of the element is 1, 2, 3, 4, whatever. That is correct. Because we do minus N or plus N every time. Well, I don't see how that's how we can exploit that fact here. So we don't need to store it. We don't need to store the previous values. So if we didn't have this clause where it says doesn't include it, I think that may be correct. But in this case, we do. So We need to have a record of all previous values. As for whether we need to store like 1, 2, 3, 4, so on, we do still need a counter to hold which number we're on. And we are at the 3-hour mark. So this is 8 characters here. I feel like there's got to be something a lot more fundamental, I guess, if we're gonna get it down to 51. So it's like 51. That's 23 characters. How do you get rid of 23 characters? There's got to be some other trick here. There is. Okay, hold on. We can change this around. Hold up. We can move this in here. That cuts us down by 2 characters. Is there anything else? I don't think we can get rid of this exclamation mark without also doing something with... Oh, hold on. No, hold on. These are all integers. Hold up. If we remove this, do that, then this would be greater than or equal to 0, or less than or equal to 0, which means this is less than 1. I'm a little bit hesitant about this one though. But maybe that'll work. Did I get De Morgan's law wrong? Oh yeah, no, because then I also have to flip these ones. That's right. Okay. Okay, we shave off yet another character. Now we're really in the in the weeds. Where we got? How? What else can we shave off here? Like, how do you get 20 characters out of this? I don't think there's anything that we can do with prints. Includes has 8 characters. But I also don't know if there's any way we can not do that. Can we turn this into some sort of math problem? But because we did say that E plus so this is E plus oh Oh, well, hold on. That's times -1. Times... All right. We can add some sort of multiplier on this, because this is either 0 or 1. Hold on, I'm going to copy that. So this is E plus times -1, which I think is still more than -n? No, that's not quite right. Hold on. Well, that's more characters anyway. Okay, so that's not gonna work. So D at n equals the stuff. Because we can probably factor out something, right? Because we can factor out... no, we can't really factor that out. I'm gonna say, like we had earlier, E plus like n or minus n. But then you'd have to wrap this in here. And we already increased our character count. And also you still have to store this part anyway, so that's not going to do it. How do you shave off 20 characters? There's got to be a mathematical thing we can do. Okay, so we're going to start looking at Rosetta Code stuff, see if there's anything in here. Because they do provide this, which means it's not cheating. Also look at maybe Wikipedia. The sequence satisfies n is greater than or equal to 0. And the absolute value of this, which is what we said, is not a permutation of the integers. Conjecture. Every number eventually appears. Alternate sequence. There's another sequence less known defined as this. I don't think is the same. That's not the same, is it? No, that can't be the same. 1, 1, 2, 6, 24, 120. Zero, 1, 3, 6, 2, 7, 13. Yeah, so that's different. Or n minus 1. I don't know. Okay, no, that's the other one there. And is new. So otherwise, we said that. It's distinctly defined as subtract if you can, otherwise add, which is kind of what we're doing. Yeah, okay. That's no help. You already know all that stuff. Translation of Haskell. And they got a set enum from to. Only that was an actual thing. Why are all the JavaScript entries so large? They really don't need to be this large. Can we find another example? Hash tables. Oh, you want Python maybe. Generators. Self.a, self.n, while true. Oh no, but this is just a generator. That's why it's while true. You have the next plus 1. If next is less than 0 or next is an A, then you add instead. This is what we're doing. We are attempting to do a fraction, and then if it isn't, then we add instead, and then we push it to the thing. Okay, so that is what we're doing. It's a little bit too large for what we're looking for. Okay. I have no idea how you shave off 20 from here, so this might be where we ended off. Just gonna have a look at some of the other ones that we've done here. So FizzBuzz, we are trying to shave off 2 characters, and I don't know where. I don't know where you shave off 2 characters. The obvious thing that comes to mind is this. You can somehow deduplicate the Zs. Sure, but I think adding them back actually ends up making it the same. That's 60 in Python, very good. I don't how closer is Python? Oh, wait a minute, hold on. Top is 58. Or are you talking about FizzBuzz? Ah, yeah, okay, you're talking about FizzBuzz. That's very close. That's about as close as I am for JavaScript. How do you get rid of 2 characters? You can't even get rid of 1 because if you do this, then you just always end up with I. Because of how bitwise operators work. Can't get rid of the parentheses because you need them for precedence reasons. Would be nice though. And moving this outside doesn't make sense because then you just use more characters. Can we somehow get rid of this? I don't think so. If you do a ++ I on something that doesn't exist, you end up with undefined. Yeah, B is not defined, which is not going to work. So we do need this. Or do we? Is there any way we can get rid of these ternaries? I'm thinking that might be where it is, but at the same time, maybe not. That's not going to work, because if this returns 0, or if this returns anything other than 0, then it returns a number, which is going to get turned into a string. Which is not going to work. And I don't think there's a way for us to check that. So it has to be this, I think. Unless I'm missing something. That increases it by 1, so that's no good. In Python, you can index a string. You can index a string in JavaScript too, but you can't slice it in the same way you can do it in Python. Well, you can slice it. It's just it requires a what do you call it? It requires a function call. So it's certainly not as efficient as that. But actually, I wonder about that. Let me see. String.prototype.slice. Because you do have index start and index end. So if you do something like bizbuzz dot whatever you have here, which I'll then translate to JavaScript. Does this exist? I think it does. I actually don't know what this says. This is not, right? Bitwise not. How does this work? But then the other question is, is this any shorter than this? Because then you end up having to do this anyway, and it's not at all shorter. So in JavaScript, this doesn't work, unfortunately. I don't know about this one. I'm not sure we're gonna get this one. Cool, that's 88 characters. And we did this in Bash. Can we get it down to 40, like, at least lower than this? And this one I'm struggling with because I can't see a way for us to cut it down. I mean, this one here was a good trick. But anything more than that, I don't want to see anything either. I think this is probably the shortest way we can do a loop, as far as I can see. We still need the do done thing. Can we do this? Surely it's a syntax error. No way, it's not a syntax error. Okay. Good to know, which means we can maybe do this. I don't think so. This one's definitely a syntax error. How is that not a syntax error? Does that mean we can do this? Yes, it does. Can we do this? No, that's definitely a syntax error. Okay, so we got this one down to 85 bytes. But I don't see how we can... I mean, I said that earlier. I don't see how we can get it down even more. N equals n times 3 plus 1. And then n divided by 2. N is not a multiple of 2, then we do this. Otherwise, we do that. S is the number of steps, so we do this every time. So I never try to minimize characters or code. Yeah, so the story goes here that the first time I did code, first time I was introduced to Code Golf was in university. There was I don't remember what it was, but there was some sort of computer science club event, and I went to it, and they were doing Code Golf, and I won a T-shirt because I had actually done. I had gotten one of the lowest scores for one of the challenges that they did. But yeah, Code Golf is fun because all you know about programming and best practices just get thrown out the window, and it forces you to think in ways that you don't normally get to think in. It also means that you really have to know the language that you're working in. That, or you learn stuff about the language as you do it. Like, for example, I didn't know this was a thing. And apparently it's a legacy thing. And I'm surprised you can't do it with loops. Or the until loop. We tried, right? You can't? Yeah, you can't. It's just explicitly for the for loop. Well, we did manage to shave off a couple of characters, so I think that's probably good for now. This we didn't even attempt. And then there's this, which, as you said, we managed to get it down from 77 to 71. We actually, I think, had it, did we, I think we were at 80 or 90 to begin with. Something like that. I'm pretty sure we were at least in the 80s. Someone in a math background that started coding for competitive programming had a really bad habit of naming variables X, A, B, and so on. Yeah, programming kind of grew out of that. in some cases it doesn't actually. So I think in was it Prolog, ML, one of those languages, I feel like it's still natural to use single variable names, but yeah, I don't know if you've ever and then there's the lambda calculus, which is programming still, although it's, I guess it's not programming language in the sense that I don't think anyone's written an interpreter for it. There's more of a mathematical concept. I'm sure somebody's built something to parse lambda calculus. Actually, a lot of programming languages are built on top of it. Like Lisp, for example, is at the very least very close to the lambda calculus, or anything functional, to be honest, for that matter. You got yours down to 67 using object as sets. This trick is to use a variable to store your previous iteration's result. Okay. 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 Let's see how we do that one. So the previous iteration's result is going to be this one, which makes sense. So I was right in that if we were to get it down to anything lower than this, or like any significant amount, then it would have to require a very drastic set of changes. So if we have an object as set, so we have this. And the question is, how do we initialize that? Then we have this. D includes this stuff. So we have then that equals, say, 1, which means then this is D at this 64. Oh, you're making a lot of progress. Okay, so then we need to figure out, and do we even still need this? I don't think so. So then we don't need this. And we have plus plus n. It works. So then maybe we still need n equals 0 in this case. Well, this is definitely shorter. We'll give you that. This is at least shorter. $61. Now let's see if this works. Fail. Exit status. Missing this after arguments list because we are syntax error. E is not defined because we have not initialized it yet. I guess this is 64. And then this is wrong. This is wrong because D equals 1. No, so the equals 1 there is intentional. Because if we're using object as sets, then we need some sort of value to say that it's there. We need some sort of truthy value to say that it's there. Because anything that doesn't have a value means that the key isn't there, and we end up with undefined on this one. So if this exists, or m is greater than 1, if this does not exist, if this exists, or yeah, okay, hold on, no, this is correct. So if we have seen this before, or if m is greater than 1. Yeah, for the case of 0. No, so for the case of 0, this is still what we want. Oh, hold up. I think I'm getting myself confused here. I'm gonna restore the solution. Have this side by side. So we start off with 0. We start off with e equals 0. With n being we're gotten off by 1. Okay, hold on. So let's start with n plus plus here. I don't like that, but it's still shorter. Okay, well let's figure that out first. So if we have n plus plus, so if we have n equals 0, and then n is less than 251, n plus plus. It prints, so this starts off to 0, which is fine. That starts off 0. Then n equals 1, which means d at m equals e, which was yeah, no, hold on. E is 0. This is fine. So 0 minus 1 is equal to m. Can't get n equals 0 to work on my version. So we get m equals e minus n, so this is negative 1. Negative 1 does not exist, so this returns undefined. Oh. Ah. This is where that breaks down, because it needs to be that then. Because undefined, or something, apparently is actually still correct. But the bitwise or here yeah, no, actually the fact that it's undefined is what gets it. Okay, so this then would be correct in that case. We go down to 66, which is still wrong because we still get a bunch of 1s. Okay, so either it's undefined or it exists. So in the case of 1, this becomes m equals negative 1. Negative 1 is not in the sets, so we get undefined, which means m, and then we go to here saying that m is less than 1, which is true. Then that means we need to add instead, and we get e plus n. Aha. No, this is correct, because you still want this here. Is it because we need to add parentheses? No, that was not it. Which is what I figured, because assignment is should be less cohesive than this. It's a lower precedence. So this should be 1. And then M, we don't get that anyway. So D at 1 is equal to 1. And then we go to 2. So 2 is here, so we go through here. M equals, so E had to equal to 1, so this is 1 minus 2. Which is -1. Doesn't exist, so that we go here. -1 is still less than 1. And so we go here. So we end up with 1 plus 2, which is 3. And that gets assigned to E. Oh! Okay, yeah, you're right, Karma. So it is because of this 1, but it's because we need to give it E. Because it returns 1, the value, because that's what we said here. We actually need to return the actual thing. And then where we have an off by 1 error. Okay, so we saved 3 bytes. This gets us down to 68. How do we optimize this? Well, we should be able to fold this into somewhere. We should be able to fold that into somewhere. Do you want information about my approach? Well, let's see how far we get here first, and then we'll see if I get stuck. Then yes. For now, let me see if I can find any optimizations here. But if you got down to 61, oh no, you only got down to 64. Which is where I got to. This one kind of sucks. Unfortunately, I have to do this. If n equals 0, then prints the thing. Now that we're storing the previous one in a variable, do we still need this? Probably in some form. I would like to be able to do the n++ integrated somewhere else. Like here. But we need n to be -1. Now I think this here was an old solution, but we had n equals -1. But we kind of need this to be 0. Plus n minus 1. Oh, no, I didn't get to 64. Okay. Where do we get to n last? Because I think we do n for sure over here. We might do n here, but it's not guaranteed. All right, 539. Let's hear it. Where there's got to be something here. Just a hint. Just a hint. Maybe this goes outside. No, that doesn't make any sense either. We have to initialize, so either we don't initialize this to anything and we have the logic for n equals 0 in here somewhere, or we have this in the initializer. We have the logic for n equals 0 prints x equals n. I realized I didn't have live chat on, so I wonder if other messages have been eaten up by YouTube. Yeah. So if we do, so yeah, I do wonder about this. So we do have this. But then, so you say you have print x equals n. So I guess x here would be e. No, that doesn't really make sense, does it? I guess it does. Kind of. But I also don't see how that saves anything. But given your other hint here, because it's only assigned towards the end of the print operation. That is true. But this here... So the reason why we needed this this comma e here is because this expression here returns the value that was assigned to it. So in this case, 1. But maybe that means that I'm assigning this incorrectly. So you have, for your for loop, you have d is this as the empty, and then n equals -1, which means you have plus plus this, and then you have this empty. And so then you have this equals n, which means we get rid of this, get rid of this here, get rid of this. D at E. Which means then we need to change this into M. Because we're guaranteed to not have 0 unless it's the first one. It's guaranteed to always be positive unless it's the first one. Maybe not M. Okay, yeah, but I think that is a very good insight, that everything except for 0 is going to be positive. I'm just trying to figure out how to form that. Something is wrong here. Okay, but I see where you're getting at. I see what you're getting at. I just need to figure out how to actually put that into code. So what is E right now? So we have an object here. So D being our being the previous ones, N being our counter. We loop through to 250. At 0, N is this, and so then we don't need to deal with any of the other stuff. E is then equal to 0. Next loop, we have N equals 1, and D at D at 0, hold on. Well, 0 will never appear anyway, so that doesn't actually matter. It doesn't matter that it's not in the array, or in the. It doesn't matter that it's not in here. Hold up, if it doesn't matter that it's not in there. If it doesn't matter that it's not in there. Still impressive, I can't even interpret anything. Yeah, when it gets down to this this few characters, it can be difficult to pick up. But hold up. If it doesn't matter that it's in there, so what if we get rid of this? Because nothing's ever going to be actually. It's not true. Not necessarily. No. It doesn't matter. So even if it is 0, it's not in here. This will catch the. This would catch if it's 0. So we don't actually care about storing 0 in here. Which means then yes, N equals -1. And we don't need this anymore. And then you have the optimization here where you have this in some form. So E is the results of the calculation. Well, I guess we can start there. Something's off. So then we'd have to do that. Oh, wait a minute, hold on. We don't need to do that because we can just print E. And then DE is something. Is E, I guess. So, I mean, it doesn't really matter what. Syntax error, missing a thing after the thing. Okay, I'm going to save 2 bytes from that. I for loop index, P for previous, M for memory. Yeah, that would make sense. I don't remember why I chose D. I think it was for dynamic. N was because of this here. And then E was because it was after D. I can get this down to 61. It doesn't even matter that this is E. I think we just... Oh, no, it does matter that it's E. Because it returns... Yeah, the result of the expression is the value assigned to the variable. So it does matter that it's E. It doesn't matter that it is 0, because we mentioned here this has to now be a Boolean OR, and it can't be a bitwise OR. Can we get rid of this at all? Don't think so. Because E doesn't exist yet. Still, we managed to shave this down by a ton. Still got 10 more characters to shave off, though. Anyway, we've already been going for 4 hours. Well, let's hope we can wrap this up soon. Is there a way we can avoid having to use -1 here? I'm thinking E equals this, N equals... Yeah, that's not gonna work. Plus D? Nope. Would have been nice. Can't do that. there any way we can get rid of these parentheses? Don't. Not in this case. Because we have a ternary here, which means this had, if without the parentheses, the precedence would be all wrong. Where else can we shave off at least one character? I think we need. We still need M for saving this result here because we use it in a couple places. I think we still need. We definitely still need D because we need to have a list of. A list of all the stuff that we've done. N is important because we need a loop iterator. Print is necessary. So we can print stuff. I don't think there's a shortcut to less than one that we've already we haven't already done. So we have here assumptions that all values except for the first one are going to be positive. They're all going to be integers, which I think we've already exploited a bunch. Still, how are they all getting 51? Hold on. How are you getting 51? How many people are getting 51? 12 people. Or 11 people. And they're all 52, 56, 57. You're at 50. E minus N, E plus N. I feel like there's definitely some sort of, there's maybe some sort of optimization you can do here. But I don't know what it is, if there even is any. Funky thing for that, but I think it's roughly a wash. Well, if it's a wash, then I guess we can see it anyway, just to see if it inspires anything. Spoiler. Well, do you have anything less than 61? Because if you don't, I don't think that's a spoiler. I do have it working at 61, yes. Alright, so let's copy this into here and see what we have. Yeah. Okay, so comparing yours to mine. I would say in there, p equals I, p equals I. Yeah, so I think we had this part before, and we can optimize it over here. So this you can rewrite to m at this equals p. So you save those characters, exploiting the fact that in your case p will never be p will always be greater than 0 for anything other than the first one. Actually, no. So you can't do that because you have this. You are making use of the bitwise. Making use of the bitwise OR. But okay, what do you have here? So I times 2. Let's just at least try to understand this. So x equals p minus I, which is equivalent to this here, plus m at x for this. So this is going to be either 1 or 0. And then times I, which is this, times 2. Which would be the equivalent here of m. In this case here, it'd be something like m plus n times 2. Which I see what you're getting at, but yeah, I think this ends up being more verbose. Good try, though. However, I wonder if there's anything we can do with that. Because if you have m... No, I don't think so. If you have m here, then you are down by 1 or up by 1 here. Yeah, I'm not sure. So we can maybe shave off 1 if we manage to figure out how to get d to be if we manage to get d to be just a 1. So then the question is, how do you do that? You can get d out here. But I think this actually adds a character. Actually it adds 2 characters. Yeah, that adds 2 characters. That's no good. Unfortunately, print doesn't return anything. We can't use that. I think I said before that we can't get rid of these braces. Or sorry, these parentheses, but can we turn them into something else? Or m greater than 1 is this, otherwise it does this. And then we assign this to the map. And it's unfortunate It's unfortunate that this is -1 because we might have been able to shave off the character there. Okay, so. Alright, let's see what we have here. Using this. So this is your current one. And then you have this, I think, over here. Doesn't that increase? Is this correct? Did I put this in the wrong spot? But using this. That is an idea. So if we move this around, this becomes... No, you still need to calculate that. So, moving this around, we have then... plus... we have M here. And then what you had was and. So if this is a thing, then you add, if this is not a thing, how is that, hold on, how is that reliable? You see M equals E minus N, I see men. Alternatively, actually no, there's no E elements. There is also no M elements. And double bond, single bond. My code has had X-Men at some point. Okay, hold on, I don't think I understand how this works. Oh, right, because you have this, which means it's going to be a 0. Or rather, it could be a 0. Because this could be 0. Right. No, it's not right. This has higher precedence, right? So this is that. If it is a 0, then this returns a 0, which means you end up with this. If it is not a 0, then it's I times 2, which means it cancels this out and adds another I. Okay. So that means if we do this, meaning that this has to be either 1 or 2. Booleans. Can we exploit Booleans? I don't think so. Hold on, let me change my code so that it matches yours. Get equals 1. So can we optimize this? Actually, this is still longer than the other one I had. But are there any ideas we can take from this? Yeah, at least do this, I think. That would bring it down by 1 character. We have not seen it before. Or if it is less than 1, or if we have seen it before and it's less than 1, then we add plus n, otherwise we add 0. Or we add 2n. I think if we shave off one more, if we manage to shave off one more character, I think we're probably good for the night. I don't know if we're going to be able to shave off another character. I'll give us until the 4 hour 30 mark. Or rather, let's give us another 10 minutes. I was not expecting to go for this long. I thought this was going to be like 2 hours. Not complaining though. DN Prince Den Demon Men Me. We're gonna start doing that. Man. I'm glad I found the site though, because I remember having a lot of fun with Code Golf back in university when we did it. And there wasn't really a good opportunity to do it again afterwards. So it's good that there's a site for this now. Why did you suggest this problem? This one's a good one though. At least it's the fact that we're spending a lot of time on this means that it's a very good one. I saw someone on the Code Golf Discord like, oh, it's an easy problem, I got it to 58. How do we shave off 2 characters? Okay, hold on. So, considering that everyone here is doing this, like getting to 51, 52, means that we're probably missing something fairly obvious. Obvious-ish. I'm still a little bit doubtful that this is the highest, or the lowest we can get for the for loop. So there's got to be something there, but I also don't know what. Because this can get you to 0. That can get you to 0. But that also uses a ton of characters. And if only we can get it to n equals 0, this wouldn't... Actually, that doesn't even matter because we don't have a 0 here anyway. Hold on. That doesn't actually change anything. I don't think this changes anything. But can it? It's not like we use the this directly anyway. If this exists, hold on. Here's an insight. With the way I have it set up now, if this exists, then that means that this hold up. What is undefined is less than 1 is false. Hold up. So the way I have this set up is that this, if it exists, is equal to m. So this then is equivalent to m is, if this does not exist and it's undefined is less than 1, which is false. If it does exist, then it means that no, that can't be right. Because we only get here if it's positive. We only get here if it's positive. But I think that's definitely somewhere. You hit 60. Oh, congrats. I think that might be an insight. I just don't know how to use it. Greater than 0. Is m the same thing? You still end up with a ternary. Can you use this directly? Because I think part of the reason why we can't use this directly is we need to check if M is positive. And if it isn't, this I don't think we can do. You can just turn... Hold on. Yeah, I guess it's worth a shot. I don't expect this to work because this is bitwise. But if it does, then great. Ow. Why does that work? Okay, I don't think this will work either. Yeah, this one I expected not to work because we rely on the short circuit in here. This... Yeah, okay, so if this is undefined, then we end up with whatever this is. Yeah, that's why. Okay, that makes sense. Because if this is undefined, then it goes to here. Which means if this is 0, then we end up with here. So that's 60. If this is not undefined, then this is going to be some sort of non-zero. Which means we end up here. Okay, that makes sense. So that, sure, I was overthinking that. Do you need the last semicolon set to 4? Yes, that is syntactic. Is required. And we can improve it just in case. Syntax error. Unexpected token. Would be nice if that weren't the case, but that is the case. Yeah, if only we could sneak I++ in the loop body. Hold up. Oh no, we wouldn't know that anyway. Yeah, if only we could sneak I++ into there. Or not have this as -1. We did get down to 60. It's been 10 minutes. We did manage to shave off the character. So I think that's probably where we're gonna leave it off for today. If you do manage to get it down to however many, we do have the programming channel in the Discord. You can definitely go brag in there. If you're not in the Discord, there it is. It's worth checking out. Like I said, we do have a programming channel. I think I would like to do Code Golf again sometime in the future, because this is good. I'm running out of cursed coding stuff to do, but this is plenty cursed in its own way, so I think this is good. All right, announcements. I seem to have forgotten to actually put in the next stream thumbnail, so let me just do that very quickly. Tomorrow, or I guess today technically, since, or at least for me, since 12:30. But anyway, tomorrow, we're gonna be doing 5D chess. The game comes with a number of intro puzzles where it teaches you how to play. And we're going to be going through those. And we're doing this because, in a sense, this will be important for later. But that's all as much as I'm going to be saying about that. But yeah, 5D chess. It's not as daunting as it looks, but we'll go through it. Once again, for anyone who has not been following along, the site that we've been on is here. This one in particular is a come on problem. So you can try to beat 60. Okay, I think my brain's starting to turn into mush. I don't know if I want to bother trying to find someone here to raid. Is there anyone here who I can raid? Otherwise, we'll probably just end on both platforms. Don't really have to. Yeah. Do I want to turn that into an A? Nah. Well, actually, then maybe there is somebody worth raiding. I don't know. But even if I do raid, I think it'd be raid and run. So we're just gonna end on both platforms for today. It's unusual, but I'm just gonna do that. It's fine. Okay. Is there anything else? I think that's it. For anyone new here, my name is Penbu. I'm the programming, puzzle gaming, and music making VTuber on Linux. Today we're playing Code Golf. Why, as the stream title says, why use much character when few character do, or whatever. Alright, I think that's it. Thanks for coming, chat. I hope you had fun. See you next stream. Bye. Also, yeah, thanks for all the help too. We wouldn't have gotten to 60 and whatever else we got for the other ones without everyone's help here, so pat yourselves on the back too.